Okay, so what we're going to do next, what I want you guys to do in class today, I'm going to explain in this little video here. So I'm hoping that that will help make it make sense. But we're moving into the next part of the unit, which is looking at graphing trigonometric functions. So this is section 2.2, and we'll actually spend several days on this section. So our learning goal is that students will construct the graphs of sine and cosine functions on the coordinate plane. So I want you to take a look at the couple of handouts that you have. And this is not something that you need to write in your notes. I just wanted to go over some of the information that's in this handout so you know what it is that I want you to do. So take a look at the one that's titled Trigonometric Functions of Real Numbers. So what you're going to be doing in this task here, okay, look, I can't even draw a straight line. What's wrong with me? The first part is you're going to graph, okay? So on the back of the paper, you'll see a couple of graphs set up that are ready for you to go. And what you need to do is create a table of values for each of the functions. F of x equals sine x, or y equals sine x, and y equals cosine x. So all you're doing is creating a t-chart, a table of values. So for example, if my x right here were -7, I would be taking the sine of -7 and I would use my calculator. The sine of -7 is approximately -0.657. So then you're going to do it for -6.5. So you're going to move in increments of 0.5 and you're just going to keep evaluating the sign of those numbers and then plugging them into your table. So once you complete your table, then you can construct the graph of the function. I want you to plot all of those points and then connect them in a nice smooth curve. So complete the table on your paper, then construct its graph. Now, one thing I really want you to pay attention to right here, make sure your calculator is in radians, right? If I'm taking the sine of -7, that's not -7 degrees, that's -7 radians, and that's a huge deal, okay? So the first thing you're going to do is fill in the t-chart, the table, construct your graph for both f of x equals sine x and f of x equals cosine x. Once you've done your graph, you're actually going to be doing a little writing assignment. So the first thing I want you to do is write a rough draft. So I want you to look carefully at those graphs, and there's a few things I want you to focus on. And I want you to write a paragraph about both functions. And I want you to compare the two functions. There should be some very obvious similarities, and there should be some very obvious differences. So your graph should include a comparison of these things that are listed here, but they should not be limited to these things. So you should be talking about or comparing and contrasting the functions in more ways than just what I have listed here. But some of the things that I want you to talk about are domain and range. Now don't worry if you don't remember exactly what domain and range is. I'm going to cover it at the end of this video here. I also want you to talk about the period. Again, I'm going to do a little instruction about the period of a function in this video. I also want you to talk about the zeros. Now the zeros are where the function crosses the x-axis, and I have a couple of examples for you to look at as well. And then whether the function is even or odd, and we'll talk about how you can tell if a function is even or odd, and I'll look at a couple of examples. So write your paragraph. Compare and contrast the two functions. What are their similarities? What are their differences? And make sure that you cover these four things as well. So after you've written the rough draft of your paragraph, when I say paragraph, I do not want it to be 2 sentences long. It should be a pretty lengthy paragraph. It'll probably take up half a page or maybe a whole page. What? Calvin, I'm busy. Go away. I love you. Anyway, so your paragraph should take up quite a bit of space, at least half a page, maybe more. Once you've written the rough draft, I want you to revise it and rewrite it. So you need to get some feedback. Share your paragraph with somebody else in the class. Ask them if it makes sense. Ask them if they think it's correct. If they're not sure, explain your ideas. Figure out how you can change the wording so it's clear. I have a little feedback handout that's going to help you look at somebody else's paper and help them to use it to give you some feedback. So it covers the four things I want you to make sure that you compare or address in your paragraph. The first of which is, talking about the domain and range. So what you can do is if somebody else is reading your paper and they read what you've written about domain and range, you're like, oh, okay, you're on the right track. It needs some refining. Maybe it needs some more detail. I'd circle that. And then, you'd put comments in right here. Okay. When you turn this in, I want you to turn in your rough draft. I want you to hand in this feedback handout that somebody has filled in for you, at least one. And then I want you to turn in a revised draft. All right, so now let's talk about those few things that maybe you don't remember so well. Domain and range. Remember, the domain of a function is the set of x values that the function contains. The range of a function is the set of y values that the function contains. So I think a couple of examples help make this clear. Let's look at this example right here. This is y equals x squared. Now, there's no reason that I can't plug in any single x value into this function, right? So I could plug in negative 1,022,000,022. I could square it and it would work, right? My function's y equals x squared. However, there are no negative y values in this function. So therefore, the domain is all of the x values between negative infinity and positive infinity. Another way we write that is with parentheses. So we go parentheses, negative infinity, comma, positive infinity. The range, however, the y values only go from 0 and up. So we say 0 is less than or equal to y, which is then less than positive infinity. Another way we write that is with brackets. We use the bracket on the left here because the y value actually is equal to 0. We use the parentheses because we never actually get to infinity. Here's another example. This is the function y equals the square root of x. This is going to disappear, but just so you have it there. Can't really write on it very good. Y equals the square root of x. Now if you think about it, we can't take the square root of negative numbers. So the domain are only positive numbers or positive x values. So the domain goes from 0 to infinity and the range goes from 0 to infinity as well because the output is also only positive numbers. We only see positive y values on this function here. So that's domain and range. All right, another thing I want you to think about is the period. So functions are called periodic if there's a pattern to the y values that repeats. The time it takes to complete one cycle is called the period. So let's look at this little example I have down below here. You can see a very distinct pattern in the y values, right? It's flat, it goes down at an angle, it comes up at an angle, and then it's flat again. It goes down at an angle, it comes up at an angle, and it's flat again. So there's a very clear pattern to the y values. Now the time that it takes to complete one cycle is the period. So you can see that's where I have this highlighted in red. If I moved this over, it would overlap the function exactly. If I moved it over again, it would overlap the function. Well, if I can get it. Come on, guy. Well, guess I can't move it. Let's see if I can move it back. There we go. It would overlap the function exactly. Okay, so what I want you to think about is what is the length of this red section, or look at the x values that go along with it, right? The time that it takes for this little red section to go through all of the y values before they start repeating goes from -8 to -5. So that's a distance of 3 units. So we say that the period is 3. All right, let's talk about zeros. Where a function crosses the x-axis is called a zero because when it crosses the x-axis, the y value is 0 at that location. So some functions have lots and lots and lots of zeros. Here's, whoops, sorry about that. Here's an example of a cubic, and you can see it's crossing the x-axis here at -3, here at +2, and here at +4. So my zeros are x equals 3, x equals 2, and x equals 4. Some functions don't have any zeros at all. So you can see in this parabola right here, since it's been shifted up, it doesn't cross the x-axis at all. It has no zeros. All right, the last thing that I want to talk about is even and odd functions. Okay, so even and odd functions are all about symmetry. Um, Now, the strict definition of an even function is that if you plug in f of negative x, the values that you get out are the same as f of negative x. And I know that seems kind of weird without a good explanation of it, but here's what that means. If you look at the y value when x is 1, that y value is going to be exactly the same as the y value when x is negative 1. So that means that we're going to have symmetry around the y-axis. It's almost as if it's been folded over the y-axis. So that's an even function. An odd function is something that's been reflected over both the x and y-axis. So it's like as if we took this part right here, we reflected it over the y-axis here, and then we reflected it over the x-axis as well, so it comes down like this. Now the strict definition of an odd function says if I plug in f of negative x, I'm going to get out negative f of x. And again, I know that's a little bit weird, so let's look at what that might mean. Here, where the x value is 1, whoops, here where the x value is 1, the y value is positive 1, right? So if I look at an x value of negative 1, that would mean the output, the y value, would have to be the opposite of what it was over here. So since the y value here was 1, the output over here has to be the opposite of that, or negative 1. So we'll talk more about even and odd functions when I get back, but hopefully this will get you started. And just looking at the symmetries, you'll be able to tell what's going on with the sine and cosine functions. So good luck, and I will see you on Thursday.